morning or good evening, everyone, depending where you are. It's morning for me. I'm from California, San Luis Obispo, and it's 9 a.m. Welcome to the webinar on data science careers. I'm glad you guys are here, and I'll try my best to make it worth your time. I am Bushra Anjum. I have a PhD in computer science with a specialization in performance evaluation and queuing theory. Originally, I'm from Pakistan. I came to the States in 2007 for my PhD degree, finished that from NC State University, and then I have been teaching and also working in industry. My last job was with Amazon. I was there for about 4 years, and I was a technical lead in the Amazon Prime program. And I have also been teaching as a visiting professor at the Cal Poly University in San Luis Obispo. Just recently, about a month ago or so, I have joined a startup in San Francisco. It's called Doximity, and I'll be joining them as a senior member of their data science team. Hence my very new expertise on the field and what it takes to get into it and what are the expectations. So let's get started. Just before that, I'm going to turn off my video because then my network connection is flaky. So let's save some bytes. Just wanted to make sure that you guys know I'm real. Well, I could be a recording, but I'm not, I'm real. All right. So this is probably why a lot of you are interested in this talk, or if you're not, you should be. Data scientists are the #1 most promising job in America for 2019, according to the report which is published by LinkedIn in January, so just a month ago. And this is no surprise because data scientist job has already topped the Glassdoor's list of best jobs in America for the last 3 years, where the professionals in the field report high demand, high salaries, and high job satisfaction. So data scientists have a median base salary of $130,000 approximately, and the job itself saw 56% growth in the last 2 years. Currently, there are more than 4,000 data science jobs which are open nationwide. So why this current boost in this job market? What has happened recently that have boosted that? Well, nearly every company now has the ability to collect data, and the amount of data is growing larger and larger every day. Big data plays into it. That is, we have the ever-growing volumes of data received at accelerating velocity from a variety of data sources, so the 3 V's of big data. And this has led to a higher demand for employees with specific skills who can effectively organize and analyze this data to gain business insights that can probably help improve a product's viability and profitability. So comes the need for data scientists. So let's try to define what is data science. There is not a single definition, and you will probably find as many definitions as the people you ask or the articles you read. I'll share a couple of them that I find most appealing and most appropriate. But first, before going to that, let's take some wisdom from one of the greatest philosophers of our time, Jack Sparrow. So what is black pearl? He was asked once, and he replied that it's not just a keel or a hull and sails. That's what a ship needs, not what a ship is. What the black pearl is freedom. So I'll try to formulate the definition of data science along the same lines, that data science is not about machine learning or neural networks or coding or complicated models or statistics. These are tools and techniques that are required but are often overemphasized when defining data science. Data science is about using data to create value for the company. And that's the first definition that I like. You can create value for the company in the form of data products, in the form of recommendations, in the form of insights. What tools and technologies you use for that is really up to you and the time that you are living in. The data scientist is primarily charged with finding value in the data collected by the company and then building some systems from it. That is to create value. The second way I would like to think about this field is that it's highly interdisciplinary. It's about different processes and systems to extract knowledge and insights from data. And I would like to think of it as a flag that was planted at the intersection of several different disciplines that were not traditionally existing in the same place. And for that, one of my favorite Venn diagrams that I found on the internet is this, and the link is here too. So you can look at data science as the perfect intersection of communication, statistics, programming, and business knowledge. So it's important to emphasize the communication and business part. Sure, you will say that every engineering job requires good communication skills and maybe some business savviness, but it's vital for data science roles, and we'll talk about it in a few minutes, that why that is. But if anything out of these four spheres is the most important one, I'll say that's the communication part. So we can say that data science is skillfully and creatively combining programming, algorithm design, statistics, effective communication to improve products or and So what do data scientists do? As you have seen already, that the definition is not very precise. Create value, but how? There's a lot of ambiguity involved. And that is why data scientists are paid big dollars, because they deal with that ambiguity. The scope of the job is vast, it's ambiguous, and no two data scientists are really alike. What they do in the industry varies considerably, but these are some of the things that data scientists usually do, not in the same order, not the same emphasis, but these are the things that you may encounter as a data scientist. The first step is to identify the data analytics problems that offer the greatest opportunities to the organization. And this is something which may not be clear in the beginning. People that hire you may not even know what they want to do with their data. This is something that you have to explore yourself and then tell them that this is what needs to be done in order to create the greatest value. And hence the importance of communication skills comes in. The second part of that is determining the correct data sets and variables. That is, you try to understand what data sources are available to the company, what data is available to the company, what data you can collect for the company. And both of these explorations require a lot of patience, a lot of meetings with stakeholders. So you need to understand the needs of the business as well as the realities of the underlying source data. You uncover these requirements via sessions with business representatives to understand their objectives based on key performance indicators, their business use cases, their analytics needs. And at the same time, you try to meet with the source system experts to figure out the data realities and what are the different data options available to you that you can use or may suggest to be used in future. Once that is done, then comes the ETL, the extract, transform, and load phase. So you collect these large sets of data, which may be structured or unstructured, and you get that from disparate sources. That's where the big data comes in. And then you do some post-processing on them, cleaning, validation of data. You ensure that it's accurate, it's complete, it's uniform. All those good things come into that. After that, mine the stores of big data. So you devise and you apply models and algorithms to mine the stores of big data and try to get some insights off of it. It may be simple statistics, it may be advanced statistics, and machine learning is really nothing other than advanced statistics. So that all comes into this step. Then analyzing the data, of course, you want to identify the patterns and trends that you have identified in the previous step, and you would like to interpret the data to discover the opportunities for business, and you would want to perhaps build some data products around the analysis and the results that you have gathered. And then the final step is you communicate the findings back to the stakeholders. You use visualizations, other means, presentations. So you start from communicating step 1 and you end up communicating step 7. And in both of these steps, you might need to convince the business that that is the right thing to do, according to your findings of the data, that the business should move in a particular direction. And you have to effectively convince them that doing that will create value for their product, which eventually means more dollars. So more dollars could come in the form of more signups from the customers, better customers retention, better press, better goodwill, all these things, better ad clicks, whatever you want to say. So all of these things eventually lead to the value of the brand that the company is creating. Now, one might say that this is way too much for a single person to do, and that is correct. As we are moving forward in time, there have been subspecialties that have been created or sub-roles that have been created. For example, the second and the third step, which is the determining the correct data sources and ETL, we have a subspecialization field which exists today in the market, which is called data engineers. So those engineers are specifically responsible for building the data pipelines, setting up the workflows that takes the data, cleans it, cleanses it, and then makes sure that it's a daily job or a weekly job, that whatever needs to be done is done and the data is available in usable format for the data scientists. Then the other group of engineers that come in, and that role is in the market too, excuse me, this one, is called the machine learning engineers. Those are the engineers which are more proficient or more trained in the machine learning algorithms. And they help the data scientists to set up that machine learning algorithms, fine tune their parameters, and do different experimentation, give the results to the data scientists, and they, in collaboration, figure out what's the best model or the best way to move forward for a particular problem. And then the third set of engineers are called data analysts, and they help with step 5 and step 6, the analyzing and interpreting of the data. So they take some of the results that have been generated by the data engineers, or they are very skilled themselves in advanced SQL, and they find out some of the insights themselves, and then they help the data scientists discuss it with them and help them move forward. So you, as a data scientist, are the captain of this ship, and depending on the size of the company, you may have co-pilots and comrades, or you may be a one-man or a one-woman show. If it's a small startup, you may be doing all of these 7 steps. If you are joining a big global company that has already established a data department, then you will have data engineers, machine learning engineers, and data analysts to help you in your goals. But there is little help in the first and the last step, which is all about communication and understanding business. And hence my emphasis that communication is the most important sphere from the interdisciplinary diagram that I shared with you guys earlier. So with this knowledge in mind, what are the skill sets or the day-to-day technologies and tools that a data scientist uses? Excuse me. So Python or R, it's almost universally required. In my experience, more Python than R. I'm personally not very well versed in R, but I haven't faced a problem with that because my Python has been quite strong. So most of the programming that is done by data scientists are in scripting language. SQL, of course, you need to know your SQLs and your joins and some advanced features too, the filtering, the grouping. So the better hold you have on writing good SQL queries, the better off you will be. Then if you are using machine learning algorithms, TensorFlow, which is the Google open source platform, scikit-learn or PyTorch, which are Python modules. One of them, having a working knowledge of one of them is good enough. If 2, that's even better. And then for big data processing and distributed pipelines, Hadoop, which is MapReduce, and Spark. So MapReduce is mostly used for the nightly backend jobs, and Spark is used for and live analysis. Having working knowledge of both will help you. I wouldn't say required, but will certainly help you. I have listed them in the order of importance according to my opinion, that you have to know Python, you have to know SQL, and then it's good to know one of the machine learning platforms or modules, and then some distributed processing. So with that, and then you are, in order to be better prepared to determine the decisions that the business would want to make with the help of the data, you also need some more generalized skills, probability and statistics. As I said, machine learning is glorified statistics and probability. So having basic knowledge of that is good. Having advanced knowledge of that is excellent. I became a good fit for a data science job because my PhD was in performance evaluation and queuing theory, which is advanced probability. So that helped me a lot. Algorithmic analysis and optimizations, good understanding of data structures, system design, especially distributed system design, and some visualization platforms. It could be Matplotlib or Plotly, Python libraries. It could be more advanced BI tools, but having working knowledge of a couple of them would help. Even advanced Excel helps. You will be surprised how many companies still use Excel, and Excel is a very powerful tool for visualizations. So with this background, I would again like to emphasize that all of these skills are good, but they fade away in comparison to the most important skill, which is excellent verbal and written communication. I cannot emphasize enough of that. And you will really, really benefit a lot from polished communication skills as in your job as a data scientist. So how do you acquire those skills? Most of the data scientists have a graduate degree, either a master's or a PhD. More have masters than PhDs, but I would say about 75 to 80% of the data scientists in the industry working currently have a graduate degree. Graduate degree in what? Well, any related discipline will do from that Venn diagram. A lot of universities are now offering a data science master's program, so that would help. A master's in computer science would help. A background in statistics would help too, or a machine learning specialization would help also. And then whatever you learn from these graduate degrees and whatever is left out from the previous slide, you can augment that skill set using online courses from Coursera, Udacity, Codecademy, or Udemy. When I did my graduate degree, Python was not part of that course set. So I did my schooling with Java and C++. So I self-taught myself, self-taught Python using Coursera and Udacity courses. So they are good. A lot of the course materials are free. If you want to go for the verified certificate, that is good too. It looks good on your resume. If you want to go for more advanced certifications, which are internationally recognized, then there are these institutes, the Data Science Association, the Institute for Operations Research and Management Sciences, and the International Institute for Analytics. So they are national and international organizations where you can seek out information about the profession, as well as certification and training options. So where do I think the field will go from here? I think we will move towards continued specialization. As you have seen that a breadth of skills is required, and it becomes difficult for a single person to be equally good in all those 7 steps that I mentioned earlier. And very few data scientists can span all of those skills. Usually when you go in, you have a working knowledge of all those steps, but you are good at 2, maybe 3. And then depending on your job requirements, you self-train yourself or polish some of those other skills. So depending on the job description and your existing skill set, that's how you choose a particular data science job posting. Different job postings are very clear in the kind of skill sets that is required, and some of them are not. As I said, business does not really know what they need to do in order to use their data effectively. So it's okay to go in not being an expert in all of those 7 points, as long as you know those at a basic level and you can self-teach yourself. Also, a graduate degree is recommended because a certain level of maturity is required to deal with the amount of ambiguity that comes with the domain. And graduate school helps with dealing with that ambiguity. And graduate school helps polish your communication skills also. So that's why it's generally sought after. So as a data scientist, you might be building complex new machine learning models, or you might be building data pipelines, or you might be building coding projects around the data and analysis and insights. So instead of front-loading yourself and trying to learn a nearly infinite amount of skills, people usually work backwards from the positions they want to have and then polish those particular skills. So to sum it all up, the expectations are lofty and the work is hard, but it's also very, very rewarding because you are deeply embedded in the business and you directly influence the business success. So that in itself is a very rewarding feeling. I will stop here because I want to have some time for questions. And before we begin that, I would also say that if you have any questions and we don't get to that, my email address is on this slide. It's banjum@communityanitav.org. feel free to send me an email if you have any follow-up question or if we don't get to answer your question here. So with that, all open to questions. If you want to type it in the chat, that's fine too. Probably we should do it that way. Let's type the questions in the chat so that we have a more organized format.
Hi, I have a question. I wonder what made Bushra to pick this as a job, something that she her whole life. Like, why exactly this? Why software developer? Why engineer? I mean, what made you pick this? No, that was actually me, Anara.
Okay, Anara. All right, Anara. So you asked me that why did I choose this particular field? Well, I can go back a couple of steps here. First is why did I choose to do a PhD in computer science? For one thing, I always knew that I don't want to go for a tenure track position. Nothing against those, but I knew that that was not. I'm not someone who would like to set up a research lab and conduct PhD thesis. I'm more adventure prone. So anything that looks like an adventure to me, I kind of jump to that. PhD looked like an adventure to me. Not many people were doing that. Certainly not many from Pakistan, where I belong. So that looked like an adventure, and doing it from a country abroad looked like an even greater adventure. So I applied for the Fulbright scholarship, luckily got that, came to the United States, completed it. And then I was looking around at what's the next best adventure for me. I love teaching. I love mentoring students. That has been always been a part of my life. So I went into teaching for the next 2 to 3 years. I taught both back home in Pakistan and then here in the United States at Missouri State University. And I was teaching undergraduate courses, and that made me realize that a lot of these students actually want to go into the industry. But most of the teachers that are teaching them, those undergraduates, computer science students, those teachers really don't have any exposure of the industry. So even with their best intentions, they are not really preparing the students the best that they can. So that became a motivation for me to go into the computer science industry and see how things are done there. I wanted to work for a big company to see how the wheels roll. So Amazon, applied for that, got into it, worked for the Amazon Prime and Kindle teams for about 4 years. It was a very rewarding experience, and I learned a lot about engineering there. However, my job there was a software developer, and I was a team lead also, but it was more development based. And I missed my original love, which was mathematics and statistics and probability and analysis. So I knew that I wanted to return to that. So taking that engineering knowledge and skill set with me, I started looking for a position that will utilize more of the analysis and probability and stat skills, and then came upon these various jobs in the data science field, and then applied for some and ended up with a startup. So I hope the journey continues well and I have more adventures to report.
Great, Bushra. Is there anything else you would like to share with everybody, or any encouragement for people who are looking to become a data scientist in your field?
It's a lot of information, as you might have guessed from these slides also. A lot of information, a vast amount of skill sets that is required, and the expectations are not always clear. So talk to people who are in the field. If you have any questions and you want to enter into this field, I'm very available to answer any questions and to help and guide you towards the next step. Feel free to reach out to me. As I said, my email is here, my Twitter handle is here, and I'll try my best to help you guys. And outside of me, also talk to other data scientists. The more opinions and perspectives you have, the better prepared you will be for this industry.
Great, thank you so much for sharing with everybody. Start with the next presenter.
That's fine.
Yeah, okay. Sindhuja, is that how you pronounce your name?
Yes.
Hi, good morning. Thank you so much for speaking as our second data scientist speaker. And, you know, like Bushra was saying, no one data scientists are going to be the same. So we're looking forward to hear about your perspectives and your viewpoints of this topic.
Absolutely. So hello, everyone. It is super nice to be here. I'm happy and excited to be giving this talk, and also specifically honored to go follow another Amazon alumni. Always feels great to know people have done similar work in the company that I work for now. Thinking about giving a talk about data science in general. Now, since the time now is all about like gadgets, I thought like, why don't I ask Alexa who a data scientist is? And predictably, and not surprisingly at all, like Alexa gave me the first line from Wikipedia entry for data science. And that's a lot of text out there on the screen. I'm actually not going to read it out. But the essence of which being like data science is a field where you have a bunch of data, where they could be structured or unstructured. And the scientist or the engineer who's working is trying to extract some knowledge or something valuable from that data. And data science has practicality in tons and tons of fields out there. Computer science is like not just one of those industries where data science is used. Data science, wherever there is data, data science is applicable. So you name it, like medicine, government, finance, like anywhere data science is a valuable field. So how did I get into data science? To be honest, like I put up in the first slide, my official role here at Amazon is actually a software engineer, but then I actually work day to day on lots of data. And so that is sort of why I wanted to talk about data science as a field. But kind of flashback on how did I end up being an engineer at Amazon working on data. So my career path is quite normal to the point of almost boring. So I don't usually try to talk about it that much because people tend to have very prolific and interesting career paths. Mine was quite straightforward. As a kid, I was always interested in computers. And when I was in elementary school, my parents put me in summer classes for like Microsoft, like learning about Microsoft Office, Fortran, Flash. I have vivid memories of making my Flash application where a yellow ball turns into a red ball and so forth, and sort of moved into middle school where I started picking up some programming languages like Java. So by the time I hit high school, I was quite sure my career was going to be in computer science. And that sort of automatically led me to do my undergrad in engineering with a major on computer science. I graduated and I became a software engineer at Microsoft. I worked there for a couple of years, and it was a very interesting role. It was one of those rotational programs where I could try my hand at different roles as an engineer. So I worked in different teams too. I worked a little bit as a developer and spent some time in a different team as doing some testing and writing test automation. I also even got to get some taste of program management. After spending time in sort of all of these roles, I was able to learn that my interests and also what I was good at was actually being a developer, writing code and producing value to the company. As much as I was like quite happy writing code, like doing application development at Microsoft, I kind of wanted a little bit more. And that's sort of where I put up this quote where this is sort of my mantra throughout my life. I don't think I really have special talent or great at something, but I'm passionately curious. I'm always wanting to know answers to questions. So I'll always try to dig deep. I'm sort of best when I'm into the weeds of a problem, trying to find like the sliver of hope out there, trying to debug stuff. So that is what interests me. And that's why I quit my job and went on to do a master's degree here in the United States, and I worked in a lab which is called InfoLab, which is specialized in data mining and information retrieval. There I worked on my thesis, which was on like analyzing and finding patterns in geolocation data. That's when I kind of knew, okay, I am where I want to be. This is comfortable. I really like it. I got an opportunity to do a summer internship with Amazon. Back then, it was a subsidiary A9 that was basically Amazon Search. I was quite happy, so I came back to Amazon, same role, same team, and I've been ever since here. It's been almost 4.5 years for me with Amazon. So for somebody who's passionately curious, what better place to work for things? And my job here is to use data to help customers find what they're looking for. Within the Amazon search team, I specifically work on the ranking side of it. So I'm hoping all of you at least use Amazon once in your life. And if you've ever been on Amazon and you're trying to find a product, I'm hoping you've put your cursor on the search box and typed in some query. So if you typed in a query and then basically hit go, you have used a search service. And my team particularly has helped you over a period of time to basically get that order of results that you see in a relevant order to you so that you can actually find what you're looking for. All of these different categories of products are backed up by machine learning models that my team builds in order to support ranking. So Bushra went quite a little bit about what a data scientist is and what different types of roles they do. So I don't want to speak about that again, but I will talk about a little bit about how my day-to-day looks like, or more like how Amazon uses data to particularly power search. And as I go through the things that I talk about and some of the lessons, you can sort of tie it back to her talk on what different parts of data science each of the work that I talk about sort of fit in. So like I mentioned, I work in the ranking team, and ranking is treated as a supervised regression problem. I promise this is the last technical slide in my talk. So this is the equation. So you have a bunch of X's, which are features of a query, a document, or both. So to make it a little bit clearer, I can explain. So let's say you type in a query. A feature of a query could something be like how specific or generic the query is, how long the query is, and things like that. And the document here is nothing but a product. So there are many, many features of a product that could be useful to find information out of. Examples could be like how many times it has sold in the past, the price, the reviews, things basically a customer would be interested in to think something is relevant. And then there are features that are common to both the query and the document, which should be something to do with their match. So how many words appeared in the query that also appeared in the document, but also more towards behavioral features like, oh, all the customers who searched for this query before, how many times did they ended up clicking on this particular product or ended up buying this product? So given all those features, ranking problem is to find this f, which is basically a function, and through which a dependent variable y can be modeled. So the training examples is a set of such x's and y's where y is the ground truth. So you already know y's for a set of x's, and you're like the training machine learning model's job is to find this f so that given these x's, you can find a y. So once the models are deployed to production, any new set of x's it sees, it's able to predict a y. The y is just called a relevance score in our particular case. So given a product and a query, you want to check what the score is. So in a series of slides, I am going to talk about some of like lessons around like data science, machine learning, or generally about data that I have learned that might be useful for anybody who works on data. While this is mostly particular to the ranking problem that is at hand, but most of it can actually be sort of generalized to any data science problem out there. So the first lesson is data engineering trumps machine learning. Well, this seems like a controversial thing to put up. It is not actually that controversial at all. In the previous slide, I said that the goal is to learn a ranking function from training data. Well, while I was in school, trying to do all these different projects, most of the things revolved around such a goal because I had very little data to work with when I was in grad school. And most of my projects involved taking a bunch of different machine learning algorithms, and trying my hand on these data and trying to find these small, minuscule improvements by using different machine learning algorithms out there. But in reality, in the industry, for most common problems, there exists a state-of-art machine learning algorithm, and mostly you're trying to use that or a version of that. But once you know that there is a state-of-art machine learning algorithm out there, how to make it good is not just to learn this machine function from a training data, but the goal sort of becomes you need to construct a data set from which a machine learning algorithm can actually learn the rank function. There is so much data out there. You'd like name it, any industry uses data, but data is raw, it is unstructured, it is noisy. So if you just put in bad data, it doesn't really matter how good your machine learning algorithm is, you are going to get garbage out. Often in the industry, collecting good training data becomes as much or sometimes even more important than actually what modeling library or specifically you use. So this is always like my first lesson. So this totally ties up to what she was talking about earlier. And this is like a core of what data engineers do, which is try to get data from different sources, you do cleaning, you do some transformations, you do filtering, you do sampling. You want to manipulate data and messages in like a really good form so that machine learning algorithms can use this data to find some sense out of it. Second, I talked about finding a relevance score. So all of you have shopped before, right? So you're trying to, when you type in a query, you want to see relevance results. So for that, like I mentioned before, since it is a supervised learning problem, I need to find Ys for a bunch of X's. So how do I know what a Y is? See, when I was in, again, going back to when I was in grad school, many of my data sets were human label. Like you give it to a bunch of human experts, you give them some query, you give them a bunch of results, and they're going to mark it as, oh, like this is relevant, this should be ranked first, second, third. Sometimes you just say, yes, it's relevant, no, it's not relevant. While that works for some small bit of data, we are talking about really, really large quantities of data. Just imagine how many customers come on Amazon and search in a day and just multiply it across all the different countries that Amazon serves its retail sites in. Well, then if you multiply it by that scale, it becomes really expensive to collect like explicit judgments. And not just that, right? What are we trying to solve here? The problem of shopping for people to find what they're looking for when they search for a product. So when I say shoes, and Amazon shows me a bunch of shoes, what I think is a good answer to that might be very different from what one of you feels is a good shoe for the query shoes. So experts at the end of it are just customers. So how we end up getting the Ys are the ground target is actually by using user behavior. We already know what customers are searching for, and they think something is relevant, they will click on it and look at it, or they would abandon it. And that is a powerful signal. And obviously Amazon has lots and lots of it. But then it's important to remember that it is noisy and subject to pitfalls. And that's again where like data engineering or data science comes in, where you know you're going to use this set of data, but then you have to do a bunch of things before it goes in. And the last but not the least, the third lesson I will like to talk about is negative examples are important too. I want you to imagine how many products in Amazon catalog actually match the query iPhone. There are a few iPhones out there, but can you imagine like the thousands and thousands of iPhone results actually available on Amazon? So when somebody types in the query iPhone, you might expect the most recent and like the good iPhones from Apple to turn up as the relevant result in the first page. But that's not all that the ranking function has to do. It has to score every product, all these thousands and thousands of it, especially even like the bad ones, not just the good ones. So whenever you feed a bunch of data to a machine learning algorithm, the machine learning algorithm assumes that whatever you're feeding it is representative. That is exactly what I am supposed to do in the real world. So it's not enough that you only show the algorithm like the good results, like the ones that people clicked on or the ones the customer ended up purchasing, but you also want to have some representative bad results in your data. There are actually many ways to be a good result, but there are even more ways to be bad. And I think I don't even have to stress on this because I'm sure all of you have some personal anecdote on how Amazon gets some search really, really wrong. But now at least you know you have a face and a name to blame someone when something goes wrong with Amazon search. A little bit in detail about how these positive, negative examples kind of work, and then I can wrap up with the conclusion. So I talked about we basically listen to the customers. So all our data collection happens from customer behavioral logs that they search for something, and then they look for a bunch of features, and then we want to mark the labels. Let's talk a little bit about labeling. Positive labels, or things that are relevant, could be any of the following things. A user searched for something and clicked on it, probably means it has something to do with the query. They not only clicked, but they ended up adding to cart, which means it probably has something a little bit more relevant. And purchasing is usually a pretty strong signal to say that the query and the product that ends up being purchased has something to do with each other. But Amazon just not only has products in its retail site, most of you are aware of all of these different offerings Amazon has, which is like a Kindle, you read a book in the device, then there is Amazon Instant Video, and there's also music. our ranking team works on ranking models for not just retail sites like products, but also many of these different offerings. And here, a positive label is something slightly different because people don't actually end up adding to cart or purchasing, right? It could be, relevance could be measured by saying how many minutes they ended up reading a book, how many minutes they actually watched a movie for, or given they searched for a song and they saw 10 songs, what did they end up listening? How long did they listen? How many times have they listened? And so on and so forth. This is all great. This is all positive things that the customers are trying to tell us that, you know, this query has something to do with the product. What about negative ones? Like those are of kind of two types, right? Customer searched for something. We showed them a bunch of products. They completely ignored a few, which means maybe they're not relevant and they don't have much to do with the query. So we collect a few of these in the data set to tell the algorithm, right, oh, these are bad. But not just that, we also collect some random samples from the whole match set. Going back to the iPhone examples, these are ones that were not even shown to the user. They are pretty bad. And the model has to see these too, so that the model gets a representation of all the different products that it needs to actually find a score for. Once all of these particular things are done, this is how we end up getting a data set. So we start with the logs, then we look at some of these positive ones, we collect them, and then we look some of these negative ones, and then we collect those too. And it goes through an entire data pipeline where there is some cleaning done, filtering done, some sampling, and there is some sorting and like converting it into structured data, into columns and rows. And then that is when it's fed into the machine learning system. And the machine learning system runs this algorithm, ends up spits out a good model, and then the model goes through a set of series of A/B testing in the actual retail space. And finally, when it does well, that's when it goes into complete production deployment. And this is how all the models are trained, that you actually now, if you go into Amazon and you type something and you see a bunch of results, the model that's running has gone through all this different cycle. So to sort of conclude on the things that I talked about, data is key. Obviously, I'm supposed to say that because this is a data science talk, but also I sort of showed you how data is important and how that sort of also says that the data scientist's job is quite important in an industry for solving problems from big data. Listen to customers. We're, after all, a customer-centric company. When we look at data, we actually look at like implicit feedback that customer gives us, and that helps us find out if something is relevant or not. And it is not just enough to know what is a good signal, it's also equally important to know what's a bad signal. And that is when the machine learning algorithm is able to make customers happy. That's mostly what I have. I wanted to keep my talk short in case you have any questions for me. I'm super happy to take questions now.
Great, thank you so much.
Absolutely.
So I've unmuted the line, so please speak up if you have a question for Sindhuja.
So I guess I'm curious about, you know, you hear a lot about like bias and algorithms and everything, and it seems to me like data science is a field where that can become a problem. Do you guys kind of take your own bias into consideration whenever you're building these algorithms?
That's a really good question. Like as somebody who works on data, I'm quite interested in that. I keep myself abreast with all like that's happening in the industry. Since our particular case is the way I talked about, our data pipeline is sort of coming from the customers. So we don't introduce any bias from the data scientists or the engineers.
Right.
But as you can see, customers do have an effect on what goes into the models, right? This was pretty much true, not just in our case, but in general in industries. So yes, the models implicitly have bias in them. So something like, you know, customers prefer cheaper items for a particular query. Sure, we end up showing them like cheaper items, right? And a query like, so you can see that this is quite a difficult problem to solve. As you see, most of the time when customers search for TV, they actually end up buying like, you know, the cheaper brackets for TV that that's required to wall mount them. So this is kind of a funny example. And then a different customer comes along and they're actually searching for TV, and they might think, well, like, Amazon's really stupid. I searched for a TV. Why are you showing me this thing that has nothing to do with the TV, right? But that is just basically because customers sort of have this kind of a bias, or not really a bias, it's more like human behavior, that you show them something that is related, they end up buying that, and that sort of goes into our model. So since we mostly work on like shopping and tracking, thankfully our biases that we have to work with are a little bit lower in terms of thresholding.
Yeah, that makes sense.
And thank you so much, Bushra and yourself, for speaking today as our first two speakers. And I think it's been very interesting for you to share your viewpoint and your perspectives of what you do. You know, like Bushra was saying, no two data scientists are the same. So we've learned a lot about what you do and what she does differently. Yeah.
Yeah. I really hope this was helpful. But I was going a little back and forth on what I should talk on. Then I thought it'll be nice. I kind of figured, you know, she would be talking about, you know, various different things that a data scientist does. And I wanted to take out like one practical thing and talk a little bit about it, and also sort of show how important data science is, right? And if anybody is trying to become a data science, I wanted to give them a glimpse into how it works in the real industry, and also compare it with how like it was back in grad school for me. So
yeah, thank you so much for sharing.
Yeah, and can I tell you, like, you know, I sometimes like, and it's Natasha.
Yeah.
I definitely am like a mathematician at heart, right? Like I used to be a math teacher, or I like algebra, I like enough of those things. And it's definitely great to have the perspective of, okay, these are some of the pathways, or these are some of the things I have done. Like just to think, you know, Bushra, it was like I did Coursera and I taught myself, and I just started learning more and more, and this is how I came into this. And you came at it like, okay, this is some of the concepts that is really important, and these are some of the real life IRL, right? Ways that it could be used. So I really believe that it's like a 1-2 punch is pretty good. And I know that someone said, Rebecca said, thank you is very helpful.
Right.
So everyone on the call, what's really going to happen moving forward is we probably will just reach out and say, hey, what did you think? You know, any questions? We don't want this to be a one and done for y'all. Like we really want it to be deliberate, such that any one of y'all is like, you know what? The pathway into data science is something that I would like to do. And that's why you have now 2, not 1, but 2 different email contacts who are more than willing to help y'all.